Hello everyone. So before we get started, if you are enjoying the videos and find them informative, why don't you go ahead and think about liking and subscribing? It really does help out, and I want to do this full time. I just want to help y'all learn how to make games. It's what I love to do. And then, once you do that, have a great day. Otherwise, you know what? I still want you to have a great day. So, with that out of the way, this shameless plug, let's get into the video. So this is what I was meaning by a diegetic approach, is when you aim, you can put this little red dot on the enemies, and it'll let you know where your shot's gonna hit. It can even be updated so it'll go to the end of your weapon's range, so you know if it's not on the enemy, it won't actually hit them. And it's not too complicated of a process. So let's jump over into the other one. And what is happening here? No, there it is. Weird. Okay. So I'm going to set this up in the weapon data folder because it's something that goes along with our weapon, so it just kind of makes sense. We're going to create a blueprint class of an actor. This will be our BP underscore red, dot. This will be the actual actor that we spawn, but we're also going to need a material. So we'll call this M underscore glow, I guess. Or sight glow, red dot glow, whatever you want to call it, that would let you know this is associated to that actor. So inside of here, we will hold 3 on the keyboard and left click because we'll need a constant 3 vector. We can actually convert this to a parameter and call it glow color. In case for some reason you want to have later on, you can have different colors. We'll add M for a multiply. We'll add a scalar parameter called glow strength. If you don't know the shortcut for that, it's just S on the keyboard and a left click. I'm going to default this to about 5 because it seemed to look pretty good, and then plug this into the emissive color. And that's all we need so far. So we'll apply that. Now let's go into our red dot. And all we need in here is a sphere. I'm going to set the scale of it to about 0.05, so it's nice and small, but big enough to show up in the video you're watching. So if you can adjust the size, you can change the object. This is just to show you the functionality of it. Let's go find our glow material. Compile that. And the only thing we want to make sure is that there is no collision on that sphere or whatever you're using for your reticle, because if there is, then it'll mess with the line trace that we're going to do and it'll just keep coming at you. So with those two things created, let's hop over to our player blueprint. And in the event graph, we'll set this up right above here. I'm going to go ahead and disconnect these because this is where the new functions are going to go. And I'm going to create 2. So there's a custom event called spawn red dot, and then another custom event called update red dot location. Why not? So we are going to, when we spawn the red dot, we will spawn actor from class, and the class being that red dot that we just created. For the spawn transform, we're just going to get the actor transform of the player, because we don't need to worry about anything complicated here. We just need to spawn it into the world, and then we're going to be immediately updating its location, so it's okay. Now we'll right click and promote that to a variable called red.ref, or whatever you want to call it. It lets you know that's your site. And then from there, we can call our update red.location function. Now what we'll do when we update the red.location is we'll take our red.ref, right click and convert it to a validated get. Because if it's valid, then we want to find a location to put it at. So the way we'll do this is, since it's associated with our firing mechanism, we'll go over to our fire function and grab the sphere trace and all of this where we're determining where our shot is actually going to hit. We'll just copy that and back out in the event graph. We can take this up further because we'll need more room to begin with. And we'll just paste it right here. No, we don't actually need that now. So when we're updating the red dot, we want to check to see if it is valid, and if it is, then we do our trace to get a location. We'll break the out hit result. We'll grab our red dot reference. We don't need to do an is valid here. We will just set actor location. And right here, we're going to do a select. You can either do select vector or just the select. I like the select down here. And when it's a blocking hit, we'll pick one location, and when it's not, we'll do another. So if we do have a blocking hit, then we want to set the actor to the location of the block. If we don't, then we want to set it to the trace end, because that'll be the range of our weapon. Now we can take all this, move it up a little bit closer, box select everything from the sphere trace, everything connected to it, all the way up to here to the select node. Then we can right click and collapse to function. And this will be find red dot location. And you can leave it like this, or you can make it a pure function. I think a pure would work. Let's find out. We'll find out together. So we'll back this up. Just like that. Then we'll do, after the set actor location, we'll do a delay until next tick. And call our update red dot location function again. Because it'll loop through to make sure, as long as we're aiming, it'll keep looping through. But as soon as this thing is destroyed, then it'll consider itself not valid and it won't do anything at all. So it'll break out of its loop. Now in our aim function, after we adjust the walk speed because we're aiming, then we can call our spawn red dot. And since that feeds directly into our update, we don't have to worry about that. So we can just plug this directly into play. Now off our release aim functionality, we'll grab our red dot reference, right click, and convert it to a validated get. And if it is valid, then we will destroy the actor. Plug this into our reverse. If it's not valid, we want to go ahead and carry on our reverse function and not worry about it. So let's jump in and take a look. And that's what we needed. And it should be lined up exactly with our aim because we're using, I didn't have it far enough. So you can see as it's kind of getting bigger, it's because it's not quite reaching the wall over there. But now we can just see how far away. This one had pretty good range. Shotgun not so much, but that makes sense. That is stupid fun. But yeah, that's how you can have, in case you want something in the world that's more kind of, an in-universe reason to know where you're aiming. Either way is fine. Either way is perfectly fine. Whether you want the HUD element to display your crosshair or, either one's good. So I hope you found it interesting, and I'll see y'all in the next one where we'll just start doing some cleanup and refactoring some things, and I'll see y'all there. Bye.